Okay, in 11 through 20, we're asked to match each equation with the best method for solving it, given that each choice is only used one time. So if we look at number 14, right, that one looks pretty basic. Sine squared x equals 1/2. To undo a square, we would square root both sides, and that would be option H. If we look for another one that looks easy, number 17, 1 over secant of x equals 2. That's a reciprocal identity. 1 over secant of x is the same as the cosine of x, which would be equal to 2. And using a reciprocal identity is option F. Okay, then if we take a look at number 13, we've got tangent squared x times cosine of x plus cosine of x equals 0. Whenever your equation is equal to 0, you can try one of the factoring methods. And since we have a binomial here and each term has a cosine of x in it, we could factor that cosine of x out to the front as the GCF, and we would be left with tangent squared x plus 1 in the parentheses. So factoring out the GCF, that's option G for number 13. Okay, then right above it, this one is also set equal to 0, and we have a quadratic form. 4 cosine squared x minus 4 cosine of x plus 1. Remember, for quadratic form, you could use factoring with your crisscross and box method, or the quadratic formula would also work. Here in E, we have the option to factor the quadratic trinomial, so that would be the best bet for number 12. Okay, when we look at let's see, number 15, 7 cosine x plus another cosine x. These are like terms, so we could combine those like terms and get 8 cosine x. So combining like terms, that's B. And then the one right underneath of it, sine x divided by cosine x, that's one of the quotient identities from the hexagon. Sine divided by cosine is the tangent. So if we used that quotient identity, that would be I. Okay, then the next one, sine of negative x equals root 3 over 2. Sine is an odd function, so the sine of the negative angle is equivalent to negative sine of the positive angle. And that would be using our even-odd identity, which is choice C. Okay, then number 19, we have a cofunction identity, and the cofunction of cotangent is tangent. So we could rewrite that as tangent of x equals 1, and that would be with A using a cofunction identity. Okay, then if we look back up at example number 11, secant squared x, and on the other side we have a tangent squared x. If you remember on the trig hexagon, our flat-topped triangles are the Pythagorean identities. So we have sine squared plus cosine squared equals 1. That's a Pythagorean identity. 1 plus cotangent squared equals cosecant squared. And then the one that we're going to use here in number 11, in order to get the same trig function, we're going to use the Pythagorean identity tangent squared x plus 1 is equal to secant squared x. So we would be substituting that identity in here for tangent squared x. We would replace that with 1 minus secant squared x. And then our whole equation would be in terms of secant. And that would be D using a Pythagorean identity. Number 20, there is no nice way we can use our hexagon to change a cosecant into a cotangent. Because these aren't squared, we can't use a Pythagorean identity. So our best bet for this one, since there's no obvious identity to use, would be J, to graph using the intersection method that we practiced in the top section.